Welcome back to part 2, and as promised we're going to start talking about the angle of elevation and the angle of depression. So very often you have applications that use one or the other, and I'd like to talk about what that means with regards to the angle. So please excuse my crude picture here, but you have a little person here looking up at a plane. The plane is going to, we assume, fly in a horizontal path. And the person down here viewing the plane from the horizontal, they raise their eyes, they elevate their eyes from the horizontal up to the plane. That is the angle of elevation. From the horizontal up to the angle at which they are looking at the plane, the path to the plane. Well, likewise, if you are in the plane, and you're traveling in this horizontal path, but the pilot looks down at the ground, they are looking down, they are depressing their angle, so they are looking down at the angle of depression. Well, if you remember from your geometry, this angle of depression and angle of elevation are the same. These angles are equal. Okay, they're called alternate interior angles of parallel lines. Use my little shorthand there, of parallel lines. And those two angles are equal. So very often, if you're given the angle of depression, but you need this angle of the triangle, that's fine. It's the same angle, and you can use that. Right? So I'd like to do an application problem, and this is the last half of that little worksheet that you printed off that I gave for you for the lesson. And so let's look at that specific example. Let's see. Let me scoop my paper up here. Here we go. So this particular problem is number 7 on page 225 within your text, and it says that the angle of elevation from a car, it's my silly little car, to the top of an apartment building is 48 degrees. The angle of elevation from another car that is 22 feet directly in front of the first car is 64 degrees. How tall is the building? So we are looking for the height of the building, which would be x. All right, we'll let that be x. That's what we want, right? And we know this distance. So we have two triangles here. We have a larger triangle with the 48 degrees. They're both still right triangles. And then we have the smaller triangle that's 64 degrees. They both share the common height of the building, which is good. That's what we want. I'm going to need this side for the larger triangle. I only know part of it. So what I'm going to do, and for the smaller triangle, I need this side as well. I'm going to label this y. So this length would be 22 plus y. Okay? So let's look at the two triangles. I have a large triangle. Let's play with that one first. The large triangle, I have this angle and I want the opposite and I have the adjacent. So the trig function that uses the opposite and the adjacent is tangent. So I want tangent of 48 degrees is going to equal x over my x or my y plus 22. Let's look at the small triangle. Smaller triangle. That one is also dealing with the opposite and the adjacent, but now I have the tangent of 64 degrees. And that's going to equal x opposite over adjacent, so x over y. Now let's talk about what you have and what you want. You now have two equations. Both of these equations have a degree value, right? But they have two variables. They have x and y. There's an example in the text in which one of these equations would only have one variable. You will use solve for that variable, and then you can substitute it in. That's pretty easy. But when you have two variables in both equations, you have to decide which one you want. Well, it's already told us. It said, how tall is the building? We want x. So I need to eliminate the y's. I need to make both of these equations equal to y, and then I can make them equal to each other and be left with equations with only x. Does that make sense? That tells you what direction you want to go. So if we manipulate these a little bit, and you can see that this is cross multiplying. Here, I can put that over 1. So here I'm going to multiply, and by the way, don't get a decimal value yet for your tangents. That will skew your answer and round it too early. So we don't want to do that. All right, now I'm going to cross multiply. I'm going to have here, I'm going to have y plus 22 times tangent of 48 equals x. Right here I have tangent of 64 times, I have a y here, equals x. Now I have them both equal to x. So if I were to put those together, I would solve for y, which is fine, and then I could put it back in and I could find x. That's a perfectly legitimate path. But it will save us a step if we can manipulate these and just have y equals, okay? So if I were to distribute this, okay, and here I could just divide both sides by tangent of 64. So that side is done, right? Those would cancel. Here I need to distribute a little bit. So I would have y tangent of 48, and then this would be 22 times tangent of 48. I'm going to move that to the other side. All right, if I move that to the other side, then I have x minus the 22 tangent of 48. I'm close. I need y equals, so I'm just going to now divide both sides by tangent of 48. And let's clean this up a little bit so that you can see what you have. You have y equals x minus 22 tangent of 48 over tangent of 48. Okay. Here you have y equals x over tangent of 64. So if you have both these y values. Now if you set those equal to one another, now I'm only left with x's, which is the height of the building, which is what we want. So we are now going to take both of these, all right, they're both y's. I'm going to set both of these equal to one another, and I'm essentially going to cross multiply here. Okay, so I would have, here when I cross multiply, I'm going to have x times tangent of 48, that's the easy one. Here I'm going to have tangent of 64 times x minus 22 tangent of 48. Now remember, all of these tangents I could put in the calculator and I can get those values. They're numbers, they're degrees. Okay? They're values of one of the sides of the triangle. We already have the degree. So now remember our goal. We have an x here, I have an x here. I need to get them on the same side. So here I'm going to need to distribute that tangent of 64, and then I'm going to move that tangent 64x over to the left. So that would give me x times tangent of 64 minus the 22 tangent of 48 times tangent of 64. Now I'm going to move this over here. When I do, I'm going to factor out that x. So I have x times, okay, over here I had tangent of 48 minus the tangent of 64 that's coming over. And then that equals what I had left over here, negative 22 tangent of 48 tangent of 64. Now it looks bad, but basically you just have x times this factor, and you want to divide and move that factor over here. All right, when you divide that and you move that factor to the right side, I'm going to, so that you can see that, minus tangent of 64. So I'm dividing by that term. Now we're going to put that in the calculator and get the value. And you will have x equals. Now let's practice putting that in. First of all, make sure that you are in degree mode. You are entering degrees. Okay? Let's turn it on. All right, so I'm going to get my numerator here first. So I'm going to do negative 22, and then I'm going to times tangent of 48, close the parentheses, times tangent of 64, close parentheses, and I'm going to go ahead and get that answer. Now I'm going to take that answer and I'm going to divide it by this difference, but I need to put that in parentheses. So I have the tangent of 48 minus the tangent of 64, and I need to close that parenthesis, remember, because I'm dividing by that whole value. Answer is 53.31, and I believe we're in feet, are we not? Yes, this problem has feet. So that building is a 53-foot building. Okay? So yes, there's quite a bit of work involved in this, and that's one reason I selected this example. I wanted you to see how you can set up the two different triangles, how you evaluate what you're going to solve, and how you would do that. And as I said, the example in the book is a little simpler. It doesn't have two variables in both equations, but that's why I wanted to give you one in the notes. I'll see you in class. Thank you.